basically we're to the south of the boundary typically. You have these really clumpy cumulus congestus clouds that, if you look on satellite, they just kind of look like popcorn, right? And then to the north of that, typically it looks a little bit more, let's say, stable. And what that means is that the clouds look a little bit more flat. They don't have as much clumpiness. Sometimes they're oriented in what we call cloud streets. And cloud streets are just kind of basically, lines of clouds, and they indicate stability. So that's what you usually see on the north side of the boundary. So basically, where you see the clumpy cumulus clouds on the south, to the south, kind of meet the relatively stratified lines of clouds to the north, that's the boundary. And if you don't have a lot of cloudiness on the north side of the boundary, but just a little bit, and you have pretty good sunshine, that means that the boundary is going to be heating. And that's good because you need instability for storms. Remember, I was talking about that stretch, right? The stretch comes from the instability. Instability just meaning a difference. Essentially, the way to think about it is the hot air balloon effect, right? The hot air balloon rises because the air inside the hot air balloon is warmer than what surrounds it. Okay, so then that creates sort of a vertical motion that once you have a rotation that's oriented in the vertical, it stretches into a tornado, like the ice skater pulling in her arms. So that's why you need that heating on the north side of the boundary. So you can look at it on satellite primarily. So to your question, Greg, that's where you'd see it. You'd probably know to look for that just based upon experience, knowing that if you have a line of storms, let's look at the satellites, let's see what's there. And then sometimes if the boundary is strong enough or you're close enough to a radar, you can actually see the boundary. You can see a little fine line in the reflectivity. And that's typically oriented usually in an east-west pattern, maybe sometimes northwest-southeast. And what I usually look for when I'm looking for tornadoes with boundaries is that typically the storms will form, let's say, to the south of that boundary, and then they start to move maybe, let's say, northeast towards that boundary. And if that happens, then once they hit that boundary, that's when the jet engine really turns up and it starts to spin really hard.
Awesome.
So
Thank you.
I got a question.